सो इज पॉसिबल। आफ्टर दैट इज द हृदय बस्ती। हृदय बस्ती के साथ में मैंने आयुर्वेदिक के साथ काम किया, और देन इट इज द पॉसिबल टू दिस पब्लिश विद दिस डॉक्टर। दिस इज द हेड ऑफ द डिपार्टमेंट ऑफ द होम्योपैथी डॉक्टर, सॉरी आयुर्वेदिक डॉक्टर इन द आयुर्वेदिक कॉलेज अपना वर्धा। सो नाउ दिस इज ऑल वर्क इज पॉसिबल। जब मैंने ये मानव बस्ती का काम शुरू है, अब उन्होंने क्या किया, अब इतना काम करे तो अपन ये सब काम एक रिसर्च स्कॉलर को दे देते हैं। तो हमने एक रिसर्च स्कॉलर को काम दिया, उसका काम अभी शुरू है, वो पेटेंट भी प्रोसेस में कर दिया हमने। जब मैंने देखा कि हर बस्ती के लिए अलग अलग पेटेंट बनाना पड़ा है, तो वाई वी आर नॉट फैब्रिकेट वन डिवाइस। तो मैंने इसलिए एक डिवाइस बनाया और उसको मैंने पेटेंटाइज कर दिया, सिंगल पेटेंटाइज किया। कोई फिजिक्स वाला हो तो ये मैंने एक ही सिंगल पेटेंट में इतने लोगों के साथ में वो काम कर माना है, हानू एंड वर्ना बस्ती के साथ, बट जस्ट द मल्टीपल बस्ती उसको मैंने नाम दिया है। एंड दिस इज द सिंगल पेटेंट, सिंगल आइडिया। This is the useful for the all type of the basti, and this is the patentized by this one design patent mila hai, and then by my name. So this is the 8 patent on this one, and all this person are working. और ये सब सक्सेस होने के कारण वेद प्रकाश मिश्रा जी ने मुझे वहाँ पे एकेडमिक काउंसिल का डायरेक्टली मेंबर बना दिया, और इज फेलिसिटेड टू मी 2 times, एंड जस्ट आई एम सिटिंग इन दिस वन। ये सब डॉक्टर है, एक फिजिक्स वाला बैठा हुआ। तो जैसा भी तुमने कंप्यूटर के 2 लोगों के बीच में बिठाया, तो मैं भी यहाँ पे इतने मेडिकल के लोगों में अकेला था, तो मैं हारता नहीं हिम्मत, बच्चा वो हिम्मत हारता नहीं। तो जस्ट यू कैन सी, अभी ये थोड़ा सा 10 मिनट टाइम है, ओके। और नाउ अंडर ये सब सोशल वाले पेटेंट है, इसमें अब मेरा लुमिनेसेंस नहीं है। जब लोग मरते थे उस समय हमने कोविड के लिए मोबाइल सैनिटाइजर बनाया था, लेकिन जो लोग डेथ होती थी तो इट इज़ वेरी डिफिकल्ट कि उनके फ्यूनरल में उनके फैमिली वाले नहीं जाते थे। तो मेरी मिसेस बोला कि उनके लिए कुछ करो, आप सबके लिए तो करते हैं। तब हमने जाके ये डिवाइस बनाया। दिस इज द 6.6 फीट लंबा, 3.5 फीट चौड़ा, और बीच में ऐसे बॉडी रखने के लिए प्लास्टिक रैपिंग बॉडी आती थी, एम्बुलेंस के हाइट्स का बनाया उसको। और उसको हमने यहाँ नागपुर में नहीं बनाया था, हमने वर्धा में जाके बनाया था, सॉरी अमरावती में जाके बनाया। और इट इज़ अ कम्प्लीटली यूवीसी लाइट बाय 360 डिग्री। तो जैसे हमने यहाँ पे दरवाजा बंद करेंगे, जो लाइट टाइट डोर था, तो अंदर यूवीसी लाइट शुरू होते थे, पूरी बॉडी यूवीसी से एक्सपोज हो जाती थी। तो उसके कोरोना का कोई भी बैक्टीरिया नहीं जिंदा बचता था, क्योंकि 5 मिनट हमने एक्सपोजर दिया, और कोरोना वायरस इज डेड विद इन द 30 सेकेंड। यह इतना हमारा बेसिक कॉन्सेप्ट था। तो हमने उस पर ये बनाया, और इसके कारण फिर हमने इसको, ये फार्मेसी का एक स्टूडेंट है, ये माई वाइफ है, मेरी वाइफ है, जो एमएससी पीएचडी केमिस्ट्री नाउ प्रेजेंटली द प्रिंसिपल इन द सेवादल महिला महाविद्यालय, और मास्टर, हमने तीनों ने मिलकर इसको पेटेंट बनाया। और इसको तुरंत हमने मेडिकल साइंस कॉलेज को डोनेट किया, सेम टाइम जब हमारा सेकंड फेज चल रहा था, जहाँ पे रोज डेथ की न्यूज़ आती थी, हमने वहाँ पे डोनेट किया। और उस समय हमारे वाइस चांसलर सर इतने इसमें आए हमारे साथ में, दिस इज द वेरी अप्रिशिएबल। उन्होंने हमारे साथ में आए, और जब ये डीन है, ये सब इनके कॉलेज के प्रिंसिपल डायरेक्टर थे, और सबके सामने इसको डोनेट किया, और ये ऐसी न्यूज़ आई। तो दिस इज वेरी इंपॉर्टेंट। जब मेरे रिसर्च में, हंसना नहीं, जब मेरे रिसर्च में मेरे बीबी का नाम हितवाद में आया, अच्छे इसमें आया, तो कौन सी बीबी अपने नवरे को काम बताएंगी? त्या दिवसापासून माझ्या बायकोने मला कामं सांगणं कमी केले। हां, हितवादमध्ये तिचा फोटो आला, शी इज आल्सो गुड रिसर्चर, और उसके बाद टाइम्स ऑफ इंडिया में फ्रंट पेज पे उसके न्यूज़ आया। तो थोड़ा सा तो बनता है ना फिर। तो दिस इज द वेरी गुड रिसर्च, बाधित देहाचे अंतर्दर्शन। और मैंने इतना फिजिक्स पे काम किया सर, उसमें कोई नहीं आता था, लेकिन इस काम में 8 चैनल ने मेरा इंटरव्यू लिया। सो यू कैन डू द सम वर्क फॉर द सोसाइटी, एंड तब जाके तुम फेमस हो जाते हैं मेन। और उसके बाद में नेशनल समृद्धि महामार्ग है, मैं समृद्धि महामार्ग से आया था, तो डर लगता था घर जाके चाय पीऊँगा कि नहीं पीऊँगा। तो मैं आया, बहुत घबराया था, पेन कागज़ लिया, कुछ तो भी बनाया। और उस समय मेरे को VNIT का एक पता था कि उन्होंने बोला था कि हिप्नोसिस हो जाता है, उसका उपाय नहीं बताया था। तो मैंने ये किया कि 150 किलोमीटर आदमी चले, उसके बाद उसकी स्पीड 20 किलोमीटर से कम कर दो, 2 किलोमीटर, फिर 20 किलोमीटर से, जब 40 की स्पीड हो जाएंगी तब पानी का स्पेस दो, उसमें से टायर जाने दो, तो आपके टायर ठंडे हो जाएंगे और आदमी भी डिस्टर्ब हो जाएगा, तो उसे हिप्नोसिस चला जाएगा। वो मॉडल हमने दिया, और ये मॉडल दिया था कि यहाँ तक जाएंगे, यहाँ पे आपका हिप्नोसिस आएगा। और ये मॉडल हमने बनाया था कि 20-20 किलोमीटर से स्पीड करूँगा, और यहाँ पे 40, और बाजू में उस समय एक भी कैंटीन नहीं थी, होटल नहीं था, पेट्रोल पंप नहीं था और वॉशरूम में नहीं था। हमने वहाँ पे डिमांड की और यहाँ पे जो एरो बताया ना, ये हमारे डिमांड के एरो है और अभी सब तरफ लग गए। तो पहले साल में 950 एक्सीडेंट हुए, इस मॉडल के बाद में 40% से एक्सीडेंट कम हुए सर। तो दुनिया में कहाँ प्रॉब्लम चल रहा है उतना भी सर्च किया और ये पेटेंट मैंने बनाया इस लड़की का, दिस इज द सिविल इंजीनियर, और ये सुभाष चौधरी साहब की बेटी है। तो मुझे कितने लोगों से अपनी फ्रीक्वेंसी मैच करना पड़ता होगा, तो मेरी एनर्जी कितनी सस्टेनेबल होगी। थोड़ी मेरी भी तो तारीफ करो यार। सो अरे त्याशिवाय लोकमतलाही पहिल्या पेजवर जसं हेलो नागपूर असते ना, त्याच्या खाली ही बातमी आली, त्यामुळे या बातमीचं किती महत्व आहे हे कळलं। उसके बाद लोग पानी का पाउच तो नहीं बन पाया, लेकिन 5 लीटर की टंकी साथ में लेके जाते थे, पानी पे डालते थे और टायर में नाइट्रोजन की गैस भरते थे। सो दिस इज द इम्प्रूवमेंट, ऑल दिस थिंग्स आर इम्पॉर्टेंट, दिस इज ऑल माय सोशल वर्क। समृद्धच्या अर्धा किलोमीटरचा मार्ग वर चालना, therefore I am working on the different topic, LED, solar cell, tail dosimetry, irradiation, cultivation, fingerprint, traffic signal, biosensor, anti microbial, हे वेगवेगळे अलग अलग सब्जेक्ट पे मैं काम कर रहा हूँ। हर सब्जेक्ट में मैंने आउटपुट आपको बता दिया है। सो दिस इज वेरी इंपॉर्टेंट फॉर दिस माई वर्क एंड आई एम वेरी हैप्पी। दिस इज द टोटल 1003 पेपर ऑन द स्कोपस and my H index is the 50 and citation is the 15,024, and on this Google Scholar 18,504 is the citation, 57 is the H index, and 10 index is the 487 and 87. So this is the directly screenshot है आपका स्कोपस का। और ये न्यूज़ आई थी डॉक्टर संजय डोबे यांचे स्कोपस 1000 शोध निबंध प्रकाशित। तो अच्छा लगता है, इंस्टीट्यूट के लिए अच्छा लगता है। आई एम वर्किंग माई यूनिवर्सिटी, मुझे पगार कौन देता है? यूनिवर्सिटी देती है, तो मेरे यूनिवर्सिटी का नाम होता है। तो हर इसने अपने इंस्टीट्यूट के लिए काम करना चाहिए। अब सर बोल रहे थे कि आपको हम कोलैबोरेशन करें तो आपके रायसोनी के साथ भी मेरा नाम आ जाएगा, कोई चिंता नहीं। मैं सब मल्टी डायरेक्शन वाला आदमी हूँ। आप मुझे प्रॉब्लम बताओ, आधे घंटे में आपको फिगर दे दूंगा, मॉडल दे दूंगा। ये डॉक्टर डोबेजी भरारी स्कोपस से झटले 1000 रिसर्च पेपर, खतरनाक डाला था। और दिस फेलिसिटेड बाय वाइस चांसलर जो भी माधवी खोड़े मैडम आई है, उन्होंने मेरा फेलिसिटेशन किया था। दिस इज अ ग्रेट न्यूज फॉर। और ये देखो ना, आरटी मेनू डॉक्टर ढोबले क्रिएट हिस्ट्री, कधी होते का आपण कोणी हिस्ट्री क्रिएट करू, राजा महाराजा होगा, पण आपण कहते हातात फक्त रिसर्च आहे, तो रिसर्च हमें सब कुछ दे सकती है। तो वी आर आल्सो क्रिएटिंग द हिस्ट्री आल्सो। सो ये पावर स्टूडेंट में होना चाहिए, रिसर्चर में होना चाहिए, हर टीचर में होना चाहिए। देयरफॉर इट इज पॉसिबल टू वर्क। एंड दिस इज द 2022ला 101 पेपर पब्लिश केले असतात, ज्यावेळेस कोरोना होता। सर्व आपापल्या घरी आराम करत होते, मी एकटा माझ्या ग्रुपसोबत काम करायचा आणि त्यावेळेस मी ते कोविडचे पण बनवले। 101 पेपर तेव्हा पब्लिश केले कोरोनाच्या काळामध्ये। जस्ट यू कॅन सी दिस इज द मॅक्सिमम पेपर इन द 2022 इन द कोरोना पीरियड। सो इफ यू आर इंटरेस्टेड देन योर टीम आल्सो इंटरेस्टेड, और मेरी टीम मेरे साथ में हमेशा काम करती रहती है। एक ही सत्र में 100 पेपर पब्लिश, ये कोरोना के टाइम की न्यूज़ है। सो दिस इज वेरी इंटरेस्टिंग वर्क ऑन दिस वन, जस्ट यू कैन सी। And in the corona period is a very good publication also, and this is on the Google Scholar। और ये मेरे 48 पे 2 पेपर है, 10 to 32 में 12, 5 to 10 में 33, 4 to 5 में 52, 3 to 4 में 138, 2 to 3 में 253, 1 to 12 में 111, 0.45 to 1 में 23। ये मेरे रिसर्च पब्लिकेशन 1103 के। एंड एक 21 दिसंबर 22 को मेडिकल मटेरियल साइंस ने research.com किया। इस फर्स्ट नंबर पे CNR राव है, फर्स्ट पोजीशन। CNR राव इज द भारत रत्न। और दूसरे पे पोजीशन पे है साबू थॉमस, इट इज द एक्स वाइस चांसलर ऑफ द साउथ में है, केरला में। और तीसरे में मेरा नाम है। अब दोनों साउथ वाले हैं, तो महाराष्ट्र में टॉप में हूँ ना, और वो आपके सामने खड़ा है, और उसको आपको मैडम ने बुलाया है मेरे को, तो मैडम थैंक यू वेरी मच। और बेस्ट मटेरियल्स में देन आई एम इन इंडिया 3rd पोजीशन, इन महाराष्ट्र इज द 1st पोजीशन। So this is the CNR of Sabu Thomas, this is myself. And I'm top 2% scientist in the 20, 21, 22, 23 and 24 is continuously by the Stanford University. And this is the, just you can see all this news on this newspaper. And now presently I'm the 0.05% in the scientist in the Scholar GPS. Yes, Scholar GPS mein rank is the 0.05%. My name is also here. And just explain the total 17% from world and the वर्किंग ऑन द पासपोर्ट, दिस लिस्ट इज डिक्लेयर माय नेम इज द 5th पोजीशन, बट उसमें केवल मैं एक इंडियन हूँ 17 लोगों में, बाकी सब फॉरेन के हैं. सो दिस इज द अगेन इज द वेरी ग्रेट न्यूज. जस्ट यू कैन सी अगेन. एंड दिस इज द डॉक्टर डोबरे एंड द स्कॉलर जीपीएस. ये अलग अलग आते रहते हैं, आपको बीच में फोटो दिखते होंगे मेरे, लाइक दिस वन. और नाउ प्रेजेंटली आई एम द इंडिया टॉप रिसर्च फैकल्टी अवार्ड 360 17-18 में मिला था. दिस अवार्ड एंड बेस्ट रिसर्चर अवार्ड आल्सो आरटीएम नागपुर यूनिवर्सिटी इन द सिस्टम. एंड दिस इज एलईडी फॉस्फर टीएलडी और फॉस्फर, ये मेरे मेन टॉपिक है. बट जस्ट यू कैन सी द स्कोपस. सो अगर अपन फॉस्फर कीवर्ड देंगे तो आई एम द टॉप इन द वर्ल्ड. If you can write the phosphor as a keyword, if you are use the LED phosphor as the keyword, I am again the top in the world. And just you can the TLD phosphor, I am again the top in the world on the Scopus. So successful stories of the my research student. ये मेरा स्टूडेंट है, इसने PhD में 35 पेपर पब्लिश किए 3 साल के अंदर, रात दिन काम करता था. और जब उसको मैंने एक रामदेव बाबा में लगा दिया, 1 साल में उसने 13 पेपर हमने उससे पब्लिश करवाया. और हर पेपर पब्लिश होता था मैं पांडे सर को मेल करता था. तो उसका पेमेंट 65,000 से 85,000 हो गया. मैंने अभी भी उस स्टूडेंट के नाम देता हूँ कि इफ यू कैन पब्लिश योर पेपर इज द वेरी गुड इम्पैक्ट फैक्टर एंड नंबर ऑफ द स्कोपर्स, यू कैन इजीली गेट द गुड पेमेंट. सो और उसको फिर जेसीपीएस में मीटिंग में बुलाया था जापान में, और देन ही इज द डिस्कसिंग विद द नंबर ऑफ नोबल लॉरेट. ये हमारा एलईडी का नोबल लॉरेट मैं नहीं था, मेरा स्टूडेंट उससे मिल के आ गया. सो दिस इज द डिस्कसिंग द नंबर ऑफ नोबल लॉरेट बाय दिस माई स्टूडेंट. सो दिस इज द वेरी गुड थिंग इज ऑब्जर्व. ये मेरा दूसरा स्टूडेंट है, इसको 43 पेपर है. इज आल्सो गुड पेमेंट इन द औरंगाबाद एंड इज आल्सो फेलिसिटेड बाय वाइस चांसलर सर. And this is my international collaborator, some of the national collaborator. I am daily discussing on this all my international collaborator. इनके साथ मेरा direct pipeline है. So some of the students, the good publication 10 to 15, they are accepting my as a postdoc fellow by all these people. और वो हमेशा हम साल में एक बार तो मिलते हैं कहीं ना कहीं, और नहीं तो हमारा डिस्कशन शुरू होता है. So my 16 student is gets the fellowship. This student in the Taiwan. And this is the student in the now presently in the German, and this is the in the South Africa in the postdoc fellow. So all students are great and they are doing. मेरे 106 पेटेंट हो गए, जिसमें ग्रांटेड 61 है, पब्लिश 22 और फाइल 23 पेटेंट है. सो ऑल दिस स्टूडेंट इज पॉसिबल. एंड उसमें मेरे को विदर्भ में सबसे ज़्यादा पेटेंट मिले थे. सूरज भट्ट सभागृह में मुख्यमंत्री साहब ने मुझे फेलिसिटेशन किया था. सो दिस इज द वेरी गुड न्यूज़. उस समय 52 पेटेंट थे. और ये मेरे पेटेंट स्टूडेंट है, इससे फेलिसिटेशन बाय वाइस चांसलर. और मैंने 3 महीने में 17 पेटेंट पब्लिश किए थे. तो उस समय मेरे को वीसी ने बुलाया था, सबको बुलाया क्लास में. तो दिस इज वेरी, डॉक्टर डोबरे के रिसर्च ग्रुप के 3 महीने में 17 पेटेंट. सो ऐसा वर्क करते रहना चाहिए, तो थोड़ा सा एनर्जी मिलती है. और एनर्जी मिलेंगी. माई एमएससी स्टूडेंट, आई एम वर्किंग विद माई एमएससी स्टूडेंट, और एमएससी स्टूडेंट भी मेरा अच्छे से काम कर रहे हैं. ये सभी एमएससी स्टूडेंट, इससे सब नंबर ऑफ पेटेंट ऑफ दिस एमएससी स्टूडेंट. दिस इज ऑल एमएससी सेकेंड ईयर स्टूडेंट एंड दिस द फर्स्ट ईयर स्टूडेंट. सो इट इज गेट द गुड जॉब. So they are doing the good work on this the MSc student also. Some MSc student get patents है. It's very interesting of this. So MSc student भी अच्छे से काम करते हैं. She is the getting the first prize in the national conference and in this Nagpur. And this is the also Marciana Sylvester. And this is the वो चालता वाला तो विजय चिन्मती, ये उसका हमने एक पेटेंट में बनाया था. And this is the very interesting by with the MSc student. So therefore interesting work by her. And now again the new is the one, it is the second Aditi Deshmukh. She is also developing the folding helmet with me, and उस पर भी हमको पेटेंट मिला था. और this is the very good work by this one folding helmet के लिए. So now this is the all my work is presented in front of you. और दिस इज द स्टूडेंट इज द एलोलाइट के लिए इनको मिला था. सो PhD अवार्डेड 80 है. आई एम फेलो ऑफ द लुम्बिनी सोसाइटी, फेलो ऑफ द महाराष्ट्र, आई एम विजिटिंग प्रोफेसर सेजांग यूनिवर्सिटी साउथ कोरिया. So my 31 book in the published at the international level, author book 15, edited book 16 और 127 chapter है. All these book are the Scopus Elsevier publication. This is the very good. All these book are very interesting. Just you can see और मैंने जो NEP में जो एक मराठी में भी लिखा था, जो स्टूडेंट के छोटे बच्चों के लिए साइंस को लिखा, उसको भी हमको एक महाराष्ट्र लेवल पे प्राइज मिला है, फर्स्ट प्राइज. नाउ ऑन द सेकंड बुक ऑल्सो कमिंग, एंड दिस इज ऑल्सो मे बी इन द सेकंड बुक आहे भारतीय वारसास्थळ विज्ञानाच्या चष्मा. हे लहान मुलांसाठी लिहिलेलं आहे मराठीतून. सो रिसर्च वर्क ऑफ सोसायटी इंटरडिसिप्लिनरी ऑफ रिसर्च इज इम्पॉर्टंट. ऑल माय फेसेस, बट आई एम वर्किंग विथ अ डिफरेंट सब्जेक्ट, and these subjects are the chemistry, electronics, computer science, zoology, geology, botany, microbiology, cosmetic technology, chemical engineering, mechanical engineering, pharmacy, management, economics, Ayurveda, society, political science, history and Ayurveda. इन सभी के साथ मेरा काम है, और then it is a good output on this one. And just you can see, this is the Nobel laureate. With this me, I am received this 2 or 3 awards. Okay, and this is the some of the award to me here. And this is the Science Journal. It is also published in the last year. I am the chief editor of this Science Journal. And so if anybody interested, you can send the publication without charge. और मुझे अभी धरणीधर गांधी अवार्ड मिला था, जिसमें 1 लाख रुपए का प्राइज मिला था. सम ऑफ द वर्क माय सोसाइटी सोशल वर्क होने के कारण. सो दिस इज ऑल्सो इंटरेस्टिंग बाय वाइस चांसलर, और ये पुलिस कमिश्नर आए थे उस समय. सो नाउ दिस इज द वेरी इंटरेस्टिंग वर्क ऑफ दिस. सो thank you very much. This is my room, and Vice Chancellor visited so many times in my room. So my lab is open for collaborator. Research laboratory is the temple for me, and my research is puja. And this is my research student. Big thanks to my student as well as my collaborator also. Thanks for your support. And this is my email ID, my mobile number, and this is my WhatsApp number. So thank you. Any questions? सर काही क्वेश्चन? हाँ हाँ विचार. हाँ बोलो. पैटर्न कैसे बनाते हैं? मैंने अपने भाषण में एक वर्ड बोला अभी, जहाँ पे लोग सोचना बंद करते हैं ना, वहाँ से हम सोचना शुरू करते हैं. अमिताभ का डायलॉग नहीं, संजय ढोबले का डायलॉग है. आपको जो चीज़ बनाना है, जो प्रॉब्लम है, उसको इमेजिन कर लो. इमेजिन करने के बाद जब पूरा पिक्चर आपके आंखों के सामने आता है, और रिवर्स इंजीनियरिंग लगाओ, और रिवर्स इंजीनियरिंग से आप फिगर बनाओ, और फिगर ऑलवेज जो वेल नोन फिगर है, जो डेवलपमेंट टेक्नोलॉजी, उससे अलग रहेगा. देन उसको लिखो, सबमिट करो, डिजाइन पैटर्न बन जाएगा आपका. वेरी सिंपल. एनीवन?
सरांचं असं आहे की सगळ्या फील्डमध्ये सरांचे सगळे पेपर आहे. म्हणजे जो मैंने देखा अभी वहाँ पे जियोलॉजी से लेके माइनिंग से लेके मेडिकल से लेके आयुर्वेदिक से लेके, यानी सर का जो वर्क है सभी फील्ड से रिलेटेड है. आणि ऐसा कोई फील्ड जहाँ तक छूटा नहीं है कि इवन मेडिकल ऑल्सो. सो तो सर्व गुण संपन्न असे मराठी जे म्हणतात, तर सरांच्या बाबतीत मला असं वाटतंय की लागू होतं सर्व गुण संपन्न प्रोफेसर ऑफ RTM युनिव्हर्सिटी नागपूर. थँक्यू सर.
Thank you, sir. With this, we conclude keynote session 2. I would like to thank our esteemed guest, Dr. Sanjay Doble, sir, for valuable insights and contributions. Your presence has made this session more meaningful, and we are grateful for the knowledge shared. Now I request Dr. Narsimachari, co-chairperson of the conference, to present a memento to Dr. Sanjay Doble, sir, as a token of appreciation, followed by the distribution of appreciation certificate. Thank you, sir. Thank you all present here. Now, we will now take a lunch break from now up to 2:45 as our next session will begin sharply at 2:45. Good afternoon to all the faculties and students. Session 3 is now starting. We request everyone to please be seated. Let us move forward to the next segment of our event, Keynote Session 3. To begin this session, I kindly invite the following dignitaries to please come on the stage. Our esteemed guest speaker for this session, Dr. Divakar Shinde, Department of Chemical Engineering, VNIT Nagpur. Dr. Rahul Khokle, Organizing Chairperson and Dean SOET. Dr. Shrikant Thote, Co-Chairperson. Professor Mahendra Ridurkar, HOD Mining Department. Dr. Manohar Golait, Organizing Secretary. Professor Dheeraj Gharge, HOD CSE Department. We are honored to have you all with us. Now, I request Dr. Rahul Khokle, Organizing Chairperson and Dean SOET, to kindly offer a warm welcome to our respected guest, Dr. Divakar Shinde. Thank you, sir. Now, may I request Dr. Manohar Golait, Organizing Secretary, to kindly introduce our guest, Dr. Divakar Shinde.
Good afternoon, sir. It's my great pleasure to introduce our keynote speaker, Dr. Diwakar Shende, sir. Sir is an associate professor, Department of Chemical Engineering, VNIT Nagpur. Dr. Shende is an elected fellow of Indian Institute of Chemical Engineers, Maharashtra Academy of Sciences, Institution of Engineers, advisor of VNIT Nagpur student chapter of American Institute of Chemical Engineers, regular member of American Chemical Society, senior member of International Association of Carbon Captures, member of Institute of Chemical Engineers, and sir is a reviewer of many international journals like AICHE, Journal of Chemical Engineering and Data, Separation and Purification Technology, Renewable Energy, etc. He completed his bachelor's in chemical engineering at National Institute of Technology, Raipur, Master of Technology in Chemical Engineering at IIT Kharagpur, and sir received his PhD from VNIT Nagpur. Sir started his career as a chemical engineer in Emerald Petrochemicals Private Limited. Then he joined as a teaching professor in April 2002 at Madhav Institute of Technology and Science, Gwalior. Sir joined the Department of Chemical Engineering, VNIT Nagpur in 2008 and working presently as an associate professor, chairing the admission process of international admission through DASA, SII and ICCR. He works in a research area of reactive separation, hydrogen generation, fly ash xenosphere, process, safety and allied fields. Sir has published more than 90 research papers in Journal of International Reports, attended and presented 70 international conferences, paper including visits in USA, Germany, Thailand, and his other key features are book chapters 7, patent granted 6, PhD guided 6 and 5 ongoing, MTech guided 6 and 1 is ongoing, BTech guided more than 150 students. Sir handled research projects amount more than 1.5 crores. Sir also handled consultancy and testing assignments amounts more than 20 lakhs. I welcome sir, and now platform is yours, sir.
ये हो गया ना, इसको कट करो सर। पीपीटी से
पीपीटी दिया था हमने, ठीक है, इसमें से ले लो। और शायद लोड भी होगा
पहले से
पीपीटी मैंने भेज दिया था व्हाट्सएप पे।
अच्छा सर, एक बार ये इसमें है क्या अभी आपके पास?
ले लो, अभी उसमें से ले लो अपना ये पार पेन ड्राइव में जियो जरा इसको नहीं करके ये
अच्छा।
लोगो तो वही है अपना बराबर है।
हाँ सर, थैंक यू सर।
Thank you. Thank you, Dr. Manohar Golaitji, for the nice introduction. It's my honor and privilege to stand before you and speak about the sustainable kind of work. In fact, the topic of the talk is biomass conversion and biorefinery, green and sustainable approach towards alternative fuel. Okay, as we know, in present day, we are moving to a very serious situation. If you think about the electricity requirement in our life, the chemical requirements, the chemical allied products requirement in our life, it's tremendously high and increasing with a very high rate. Okay, and that is creating the problem in one or the other way. For example, the temperature rise, the ambient temperature is rising in the alarming level, right? And the medical problems and all other issues are coming. It's all because of the technological advancements and our dependency on that, right? For example, if you look at the requirement of the gasoline fuel, requirement of diesel fuel, a huge, tremendous requirement we have, and we are unable to, sustain with the present stock available on the planet. And therefore, we are bounded to think some alternative ways in what way we will mitigate our requirement, and that's too in the sustainable way. So a thought have been elaborated through the work and through some existing points. Yes. So if you look at the introduction, I will be talking about the societal needs like energy, okay, including electricity, heat, transportation, fuel, right? The another requirement of society is organic chemicals, okay, which will be using in terms of your daily needs, right, in one or the other form. Similarly, the polymers, okay. So at the moment, more than 80% of energy and 90% of organic chemicals in the world are derived from the fossil fuels alone, okay, and therefore it is getting depleted with very high rate, okay, and 1/10 of the percent, 1/10 of the percent may be the regenerative in kind, right? And therefore we are bonded, and it is our humble duty to think about the alternates. Yes, the motivation of this talk is the increasing energy demand, gradual depletion of the fossil fuels, shifting dependency away from the limited fossil fuels to carbon neutral renewable resources, right? That is what the motivating point is. Avoiding dependency on imported fossil fuels so that our economy will be established, the dependency on other countries will be minimized, right? Then addressing the farmers' distress. Okay, nowadays we are thinking that, or we are we are seeing that the many farmers are making suicides. Okay, that's because of their scarcity in their income scenario. Okay, and because of the scarcity in their income, they are committing the other kinds of way like suicide and their distress, right? So addressing farmers' distress and stabilizing prices of agri produces. New agri-business models, okay, in what way the newer model can help out the situation and the farmers conditions in terms of economy. And the biomass, okay, unlike other renewable resources, has tremendous potential, because as you will understand that the generation of coal, okay, cannot be taking place in some months or in some years. Okay, it needs thousands of years. Okay, whereas biomass can be produced in 4 months or 3 months or in a year in a huge way. Okay, so that is what the potential biomass carries, right? So biomass has tremendous potential to deliver societal needs of all usable forms of energies like electricity. You can generate electricity using biomass. You can generate heat using biomass. Okay, you can generate the transportation fuel using biomass. So that potential we have to tap. Okay, and we should try to solve the problem by using this route. So organic chemicals also you can produce from biomass, the polymers also you can produce from the biomass, and therefore the biomass, the waste biomass, you should not be ignored, and it has to be utilized in the constructive way to mitigate the present demand. So about biorefinery, what biorefinery is? Something like petroleum refinery. In petroleum refinery, what we do, we import the petroleum crude oil, either import or you produce in the some locations in India, right? And that petroleum we fractionate into various products, including diesel, including your gasoline, LPG, heavy cut residue, and many more, right? So something like this, okay, the biomass can be produced, the various products analogous to gasoline, diesel, and many more. Yeah, so petroleum refinery uses petroleum crude oil or natural gas as a feedstock to make arrays of products like gasoline, diesel, kerosene, tar, petroleum, platform chemicals, and polymers. Okay, so in case of biorefinery, a biofeedstock, okay, to which I am calling now the biomass, is used to make arrays of products like biochemicals, biofuels, specialty products, okay, specific to the feedstock, right? So what I am trying here is trying to tell you that the biomass, if you use, the dependency on the petroleum crude oil can be minimized. Okay. Yes. So typically high value, low volume. Okay, so the associated tag to the biomass is, if the volume of the biomass is very high, its value will be less. Okay, if the volume you can bring down to the lower limit, then the value of the biomass will be high. Okay, so that is what the thumb line regarding the biomass is. Typically high value of low volume, and high volume, then the value will be less. Yes, so sequential extraction of valuable products. Okay, so here what we have to do, we have to get generated the similar products, okay, which we may get from the petroleum refinery, okay, and that's too in the sequential way. Okay, so instead of using biomass for a single applications, it would be beneficial to develop an integrated approach for multiple applications, right? Use of grass, agri residue, peels of various fruits, right? Then seeds of value-added products. Okay, so all those we have to convert into value-added products. The approach reduces to carbon footprint and the environmental impact. Okay, and if we do that, it will be reducing the carbon footprint and its sustainability will be high. It offers an opportunity for developing a smart circular economy, right? So in this way, we can generate and develop the circular economy kind of concept. This diagram will elaborate in what way it will be circular, right? So you see the CO2 getting generated from various activities of a human being will be utilized by the plants, okay, and that plant then we will process in the biorefinery and will generate the biofuels, heats, okay, heat in terms of electricity, then biomaterial, okay, and our duty, our requirement will be fulfilled, and again it will be circulated again through the form of CO2, right? So that is what the circular economy or biorefinery concept is. Yes, here the biomass you may get from various sources like forestry crops. Okay, so in forest, all the foliage or the waste wood, okay, that will be the biomass in one way. Then the agricultural crops and residues, okay, whatsoever the leftover used to be in the agricultural practices, so that will be the source of biomass. Then sewage, okay, sewage waste also can be treated as biomass. Then the municipal solid waste, again the animal residues, industrial residues, okay, which will be having the characteristics analogous to the biomass, right? So those will be the feedstock to the biorefinery as biomass, right? Now depending upon their nature and sources, okay, you can classify the biomass. Okay, in fact, the first one is energy crop. Okay, certain kind of biomass you can generate exclusively for the particular purpose. Okay, and for example, you might have heard the Jatropha. In earlier days, there was much hue and cry to generate the biodiesel through Jatropha, right? So similar to that product or that crop. Okay, so those are called the energy crop. Grasses such as switch grasses, miscanthus, bamboo, sweet sorghums, and many more. Okay, then the agricultural residue and waste, okay, whatsoever the leftover used to be, so that becomes the agro waste or agricultural residue. Okay, stalks, then leaves, husks, cobs, animal manure, okay, all those. Then forestry waste and residues, biomass resulting from the forest management operations, thinning of young stands, and removal of dead and dying trees. Okay, so those will be the forestry waste. Then industrial and municipal waste, food processing, waste paper. Okay, so all those become the biomass and can be classified in this way. Then triglyceride feedstocks, vegetable oils, animal fats, waste cooking oils, microbial oils. So those are the sources of triglycerides and component of biomass. Then sugar and starchy feedstock, sucrose containing biomass, for example, sugar beet, sweet sorghum, sugar cane, etc. Then starchy biomass, okay, containing wheat, corn, barley, maize, etc. And lignocellulosic feedstock, right? So these are certain categories of biomass. Now the building block chemicals, right? In fact, most of raw material consumed and final products produced by chemical industry are made using a limited number of low value chemicals with simple structures, and those are the building block chemicals. At present, petroleum industry uses either uh, naphtha steam cracking or ethane fraction of natural gas. Okay, so that we have to shift to the sustainable way, and biomass is one of them, right? Syngas, olefin, aromatics like benzene, toluene, xylene. Okay, so those are certain kind of building block chemicals, and you can generate it from the biomass sources. Some of the typical chemical structures you can go through, right? And they will be getting utilized to generate the next kind of material. Okay, and you can start or you can use it as intermediates. Yes. Then in what way you can utilize the biomass? Okay, so in terms of physical methods, you can utilize biomass through the thermochemical methods you can use, through the biochemical methods you can use, right? So if you use the physical methods, biomass can be crushed, grinded. Okay, its volume will be reduced, and you can use it as solid fuel, right? For example, if you might have heard the cotton straw can be crushed, can be compacted in a form of pellets. Okay, and can be used as substitute to the coal, right? So already there is a guideline and mandate from the government that at least 20% of biomass briquette or biomass pellets you have to use in the coal fired boilers, right? So this is how the government is pushing to get utilize such kind of biomass and lower the dependency on the fossil fuels, right? Then the other method or through the physical method, you can have the drying and create the solid fuels, right? Pelletization, briquetting, right? So all those are the methods by which you can use the biomass, and the solid fuel will be there. That solid fuel will be substituted to the coal, right? Then thermochemical method, right? Thermochemical method involves combustion, gasification, torrefication, pyrolysis, then hydrothermal liquefaction, right? Which will be giving you the gist of petroleum products, similar kind of products to petroleum, right? And you will be having the heat energy, syngas and fuel gas, then bio oil, biochar, okay, biogases, okay, and those will be utilized as like the petroleum products we use in various kind of activities, right? Similarly, the biochemical route also you can adapt, and you can convert the biomass into bioethanol, biogas, right? And that will be drastically reducing the dependency on the fossil fuels. It depends upon how much extent you are pushing for its applications and for its conversion. Yes. Now, some case studies I will try to cover up here. The one is waste potato biorefinery, how the potatoes can become the feedstock for the biorefinery, right? Then waste organic orange biorefinery, and the straw biorefinery. Yes. So we see that after having certain use of potatoes, okay, or you cannot entirely use the potato. Some potatoes may go in waste. Okay, so such wasted potato you can put them into practice of a biorefinery, and you can generate many chemicals and energy out of the waste potato. So this is the waste potato, and it will be the feedstock for the potato biorefinery. It will be converted into antioxidants and polyphenols, right? Again, the gallic acid, food preservative, you will be trying to generate out of that waste potato. Then hydroxybenzoic acid, fuluric acid, comeric acid, right? Then separation and recovery of ultra dilute solutions is a real scientific challenge. Okay, what happens in the practice of biorefinery? You may not get the exactly desired concentration of your fuel or of the chemical, right? So you need to enhance the concentration, okay, and for that you have to face the challenge. You have to do some R&D, right? So that the dilute streams coming from the biorefinery, the dilute streams coming from the such practices, okay, can be concentrated, okay, by virtue of the technology and understanding you have, right? So challenges lies there, and we have to mitigate that. Then protein-rich dietary fibers, burn wound healing bandages. Okay, so those are certain utilizations of the products coming from the potato biorefinery. Similarly, the waste orange biorefinery. Okay, waste oranges also used to be there. Okay, because of the unseasonal rains, right? And the unseasonal, kind of diseases the farmer used to face on their crops, right? So many foliage used to be there of the orange, right? So those orange you have to utilize, okay, by making a certain circular kind of economy practice, right? So globally, Nagpur is famous for oranges, as we all know. Annual production of oranges in Nagpur division is around 1.85 lakh tons annually. Estimate suggests that 30 to 40% of oranges produces are waste, which amounts to 50,000 tons annually, right? So if you convert this 50,000 tons of oranges or orange waste, right, annually, you will be generating a parallel economy, right? And the farmers distress can be minimized, can be lowered, right? So sources of raw material, maybe waste orange due to untimely rain, right? Waste oranges in mandi due to poor transport and storages, okay, because of the transporting problem, because of the storing issues, okay. So certain kind of fraction of uh, oranges used to go in waste, right? So that we have to minimize. And if already waste, okay, so you have to process it in the viable way, right? Then waste collected from roadside juice centers, okay, so that also you can take, you can collect, and you can process it in the biorefinery. So you can see the peels of the oranges also useful. the pectins and all other kind of value-added products. You can have essential oils, then ethanol, syngas. You can manufacture from the waste oranges, right? Only thing is very systematically you have to process it, very scientifically you have to process it. Okay, so you will be getting the essential oil of very high value, pectin of very high value, ethanol and syngas. It's very analogous to the gasoline or your LPG kind of products, right? These are certain steps through which the waste oranges can be converted into those products, right? uh, Reception, then segregation, okay, with cleaning, juice extraction, orange waste, okay, drying, dry milling, okay, and to the orange biorefinery, right? So you will be converting those waste oranges into the value added products, and the economy of the farmers will be enhanced. Certain applications and the market of pectin, if you want to go through, right? So you can see the pectin, okay, the data, I mean, the input we do of pectin, and that is to the tune of $16.09 million annually we import, right? Its application lies in food industry, right? In terms of food products like jams, jellies, frozen foods, and more recently in low calorie foods, this pectin is being used. Okay, so this much of millions of dollars you can save, okay, and you can give it, or you can extend to the existing farmers of India, right? If you smartly convert the waste oranges into this product like pectin, right? Similarly, you look at the essential oils of orange and its market, $21.56 million, right? Its applications also you can see is the most widely used citrus essential oil due to its anti-inflammatory properties, right? Majorly essential oils find applications in the personal care, cosmetic, food, beverages, pharmaceuticals, right? So these are the applications of some of the products coming from the orange refinery, orange biorefinery. Then the straw biorefinery. Straw means the after harvesting of rice, after harvesting of wheat, whatsoever the leftover used to be, that is called straw, right? So the overall straw production in 2017-18 data, wheat straw is around 99.9 millions of tons, and rice straw 112.7 million of tons in the new uh, is the new high, with assumed residues to crop ratio is 1.3. The wheat straw and rice straw produced amounts to 129.6 million tons and 146.5 million tons respectively. So that the data available by that time. The Vidarbha annually production in 2017-18 of cotton 2,500 million metric ton, soybeans 2,200 metric ton, and wheat 6,650 metric ton, right? So this much of the potential the Vidarbha itself can have, and if there is at some centers, if we create the facility to process such kind of biomass and convert it into the useful products, as I just elaborated, right? The dependency on the petroleum fossil fuel can be minimized. The at the same time, the dependency on the very especially product, main product can be minimized, and parallel economy for farmer can be developed, right? So this is what a new kind of approach and model we can practice, right? The process flow diagram of a typical biorefinery, especially the straw biorefinery, can be like this. Okay, the wheat straw, in what way you can convert into various products, okay, so that you can line up through this process flow diagram. And then you will see that where is the market. So you can see the available market in various forms, right? In terms of technology, their applications, and the market estimates, right? So right from edible wax, bio oil, okay, biochar, biogas, manure, cellulosic fibers, okay. So all you can extract or you can convert into and sell suitably, okay, by producing through various technologies like pyrolysis, composting, enzyme treatment, hydrolysis, liquid extraction, and many more. The future scope may be, right, you can similarly look at on tomato production, onion production, right? At one point of time you may see that a huge quantity of tomato go in waste, huge quantity of onion go in waste, right? So in what way that waste can be, you know, converted into the useful products and all. So that is what my point of talk is. Then banana, pomegranate, pineapple, mango, guava, papaya, flowers, Ayurvedic herbs. Okay, so all those, you know, maybe waste and one point of time, right? If smartly the situation you can tap, right? You can convert those into the various useful products, right? Then the development of a protocol, the extraction of chemicals may be one of the route. Then if you get the chemical that may be soluble in polar solvents, may be soluble in non-polar solvent, and you can store it suitably, then the another route may be fermentation, okay, which will be generating the fuels, fibers, okay. Then another one may be manure, converting of biomass into manure, right? And you can generate the biofertilizers. Sir, can I proceed or stop here? I will discuss one of the other product is bamboo. Okay, in Vidarbha, in some locations, bamboo is predominantly available. So that bamboo is having huge potential and market. Okay, if you convert the bamboo biomass into the useful stuff and all, right? So that will again will generate the parallel economy for the local people, okay, who stay in and around the bamboo clusters. So this may be, one of the solution to the present day problem if smartly we convert such kind of bio waste, okay, or biomass suitably for the purpose of economical growth as well as the solution to the existing problem, right? The challenges may be feedstock diversity. Okay, sometimes you will be getting the feedstock and sometimes not, right? So that diversity, how you can cope up, so that will be our challenge. The another one may be biomass collection and transportation, right? Because the people now do not want to put more energy and efforts, okay, in agricultural practices. Okay, so in what way you can solve these problems, that is one of the challenge. In what way you can take help of the machineries and all, right? So that is one way. Then the other one is market and economical viability. Okay, sometimes the market of these bio-based or biomass-based products may be there, sometimes may not be, right? So how you can work upon to make it very regularized. So that is the challenge we have to face, and we have to get the solution of that, right? Then separation and downstream processing, right? So how we will be segregating the good product and the waste product. So there also we have to play major role. Then machinery for marginal farmers. Okay, the farmers in Vidarbha or in India may not be well conversed into the such kind of smart practices. Their economy may not allow to do these practices. So that is also one challenge, and how we have to solve that. Okay, so that thing we have to work out. Then technology foresight, okay, policy formulation, social and ecological impact assessment. right? So those are certain things we have to address in a very judicious and wise way. So I acknowledge to GH Raisoni University, Saikheda, and Raisoni Group of Institutions for inviting me and providing the opportunity to talk before you, and my own institute, VNIT Nagpur. Thank you. So if you do have any query, I will be happy to answer. Any query from online participants? Okay, so no query. Thank you. Thank you very much.
Thank you, sir, for his valuable insight. To conclude keynote session 3, now I request Professor Mahendra Ridhorkar to present a memento and certificate to Dr. Divakar Shende. Thank you, sir. I kindly request all faculty, please come front of stage from a group photograph.
नहीं वो वही डिस्प्ले यहाँ पे नहीं होगा ना, इसमें नहीं होगा, इस पे ये किसका मेल आईडी है?
कैसे कर
किसी का क्या
have a quick understanding about sustainability in civil engineering. So many a time sustainability, sustainable practices, these words are nowadays kind of buzzwords, but that many of the especially academia and student community have a surface level understanding. They don't have that clarity about what exactly goes inside the sustainability means. So in this slide, I have tried to cover this. So basically, we will understand sustainability from three major pillars. First one is the material sustainability, then energy efficiency, and finally the waste minimization. So sustainability is a very broader term. To what extent we can achieve the and what scientific principles can be followed. That is what is the agenda of this particular keynote
Sorry to
session.
this.
Hello. Samyak sir, actually, there fortunately there is a weak signal. My end. Hello. Am I audible?
Yes, sir. Yes, sir. You are audible.
Okay. So sorry for that weak signal. Unfortunately, just power went out. Anyways, but I'll try to put our best. So like I said, understanding sustainability is the first step. So how to understand sustainability? Basically, we can understand it by three different approaches. That is nothing but material sustainability. Means what? Using renewable, recycled, low carbon materials. But before using them, we need to understand them. Whether they are really renewable, recycled, or whether they have the necessary technical potential or not. Then second approach could be energy efficiency. Optimize efficiency, utilizing very renewable approaches can also help us in understanding the energy efficiency, thereby contributing to sustainability practices. So energy efficiency in design and construction processes plays a very crucial role these days. And the last one is waste minimization. Through circular economy and lean construction, this is possible. Waste minimization, because you know that construction industry is one of the largest waste producing industries known today, especially the C&D waste. Ultimately lead to achieve the goals of sustainability and thereby understanding the sustainable practices. There are different key global initiatives taken by different international organizations like United Nations have defined sustainable development goals. Then IGBC, Indian Green Building Association, then LEAD, ECBC. So these organizations are continuously upgrading the standards of measuring sustainability, continuously putting or defining the processes through which sustainable construction or sustainable practices can be adopted, and thereby we can measure the sustainable ranking. Coming to this overview of sustainability in civil engineering, so we need to understand two basic things here. One is definition and importance, and second is the global standards and certifications. So definitions, I mean to say, sustainability in civil engineering basically it refers to building practice present needs without compromising future generations, emphasizing the longevity and environmental stewardships of projects, especially this sustainability. If you look at the origin of this word, it came from the Ayurvedic term Pancha Mahabhuta, where the entire balance of the universe in nature, we call it as Prakriti, is basically depends on these five pillars of Pancha Mahabhuta. So whenever there is a uh, uh, damage, or we can say disturbance or balance in one of which causes uh, the natural imbalance, which causes that sustainability cannot be achieved. Or we, while doing this progress, we have to ensure that these Panchamahabhutas are not disturbed, meaning that we are following, we are not excessively using the natural resources just to uh, complete our own purpose. Right. obviously. So these things can help us in getting the sustainable development in overall civil engineering. However, if you want to understand civil engineering, they are very clear and concise. First one is environmental emission and the climate change effects that are now we are continuously witnessing. So if we can adopt certain sustainable measures, sustainable practices in the construction, definitely over a period of time, it is going to reduce the environmental impact. So sustainable engineering aims to minimize the footprint of civil works by using renewable materials, reducing waste, conserving natural resources during construction and operation. Then what can be the second benefit? Obviously, it is directly related with economic efficiency. The objective focuses on creating cost-effective solutions that. Yes. Hello.
Yes, sir. Share the
Sir, your voice is breaking. Can you-
uh, can you share the screen, sir? Because it is not visible. PPT is not visible. It is.
Sorry, sorry. I don't know how it has gone back. Is it visible, sir?
Yes, sir. It's visible now.
Right. Objectives of sustainable engineering. Basically, I was talking about what can be the basic three objectives. So it talks about environmental impact reduction, economic efficiency, and social responsibility. So in order to achieve the sustainable by adopting sustainable practices, we need to set certain goals. So these are the obvious goals. One can understand and accordingly plan the research strategies to minimize the environmental impact. Economic efficiency means this basically focuses on cost-effective solutions. For example, low-cost housing, cost-effective materials, energy-efficient material, which ultimately reduces the project expenses over the life cycle, including energy savings, material durability, and lower maintenance costs, etc. Social civil engineers are supposed to be a social person. The projects are designed to enhance community well-being and quality of life, ensuring equity, accessibility, and positive social impacts on local populations. Then we will understand eco-friendly construction materials. Like I said, the first approach towards is understanding sustainable materials. So eco-friendly construction materials, we can understand it by three different key parameters. First is recycled materials. Second is low carbon footprint materials. The renewable resources. So if we talk about eco-friendly construction materials, materials can be manufactured by using recycled materials, means already existing materials. After doing certain processes, we can convert them into a usable construction material. For recycled materials involve reclaiming waste products and repurposing them for construction. So this basically reduces landfill waste and demand for virgin resources, promoting a circular economy. Second is low materials. development. These days, smart cities and sustainable transportation systems are getting a huge importance from the perspective of sustainability and sustainable development. They play a crucial role. So smart cities integrate digital technology and data analytics to enhance public services, transportation, and infrastructure, sustainable urban environments that improve residents' quality of life. Whereas in case of transportation systems, sustainable transport system encourage the use of public transit, walking, and cycling, reducing reliance on the fossil fuels and minimizing traffic and gas emissions. Life cycle assessment, after understanding these sustainable practices, plays a very important role because life cycle assessment basically gives us the overall picture about the effectiveness of these strategies. So assessment techniques and cost benefit analysis can be done to understand that which sustainable practice is effective in which type of situation. Then waste minimization and management, especially on-site recycling and waste management systems are available nowadays, which definitely help converting the waste into wealth. So by utilizing the construction, demolition waste, and other construction activity waste, one can minimize this effect also. Energy saving construction techniques, so prefabrication, modular construction, efficient machinery use, these are the cutting edge technologies which basically saves a lot of time, material savings, and labor cost effectiveness. So this proves to be a very good solution for sustainable practices. In emerging trends basically involve technological innovations in construction such as automation, AI, and advanced materials are streamlining processes and improving efficiency, ultimately leading to safer and more sustainable. So we cannot deny the power of AI these days, as it is penetrating each and every field, whether it is healthcare, construction, education, software. It is not less in case of sustainable practices also, because it helps us in automating and improving much of the sustainable practices, thereby actually saving the cost and manual effort. Circular economy in construction basically focuses on minimizing waste and making the most of the resources by reusing materials. So like e-waste is again gaining a very huge popularity in urban cities, where e-waste basically it's an electronic waste which is reutilized for manufacturing and construction of different electronic devices. So circular economy, reutilizing such material from waste, which promotes sustainability and reduces environmental impacts. Challenges and opportunities are huge. Even though it looks very fancy word, sustainable, we can save a lot of energy, lot of material, we can save the environment, but practically speaking, it is equally difficult. Difficult in the sense it is having a lot of challenges. But having said this, when we talk about challenges, the past research and the past development, especially in the last decade, have shown there are a lot of opportunities also. So technical challenges, challenges in often involve adapting new technologies, ensuring quality control, long-term impacts, market opportunities. So it's a blend of challenge and opportunities whenever we talk about sustainable practices to be adopted in construction. Now there is a very crucial role which is normally neglected or may not be most of the time it is not understood in the right sense. So these are government policies. So international guidelines and some national regulations are, especially National Board of India (NBC), or some international guidelines which talks about different sustainable practices which can be adopted in the construction sector by different domains like structural engineering, environmental engineering, water, meteorology, transportation, construction management. So for every specific domain, there are certain guidelines which can be utilized to definitely reduce this impact. So government policies are in place. However, their penetration and their implementation needs to be is required to be enforced in more ease way. Certification, these are the two worldwide recognized certification: leadership in energy and environmental design. Basically, this certification benchmark design construction, and then second one is BREEAM. So building research establishment environmental assessment method is a sustainability assessment method for master planning projects, infrastructure and buildings. Economic incentives, of course, having achieved this, tax benefits and grants and subsidies, these basically are the incentives to motivate, to encourage, to adopt more sustainable practices. Then innovative sustainable practices, if you broadly classify, we can classify them: use of bamboo as enforcement, green concrete and supplementary cementitious material, rainwater harvesting and stormwater management in urban design, energy efficient building materials, and sustainable transportation. So like I said, there are various approaches. Till now, we have discussed about the overview about the different sustainable approaches. Now it is that what exactly the material or what exactly the technology should be used or can be used or is being used in last few decades to achieve this sustainability. Now, like I said, I will be focusing more on bamboo, a natural sustainable material. It's a fast growth rate and renewability. It is very having high strength to weight ratio, and carbon sequestration benefits are huge compared to other materials. So basically, if you talk about bamboo, bamboo is typically a grass. It's not a tree. It has a certain geometric and the anatomy of bamboo can be understood with the help of this diagram. You can see it is having a node, an internodal section, the culm, and the culm are having branch node. The branches are having leaves and branch growing from nodes. Then if you talk about the matured bamboo, it looks something like this, which is a combination of a group of different culms kept together. If you look at the structure more closely, so if you see the cross section of a bamboo, it is having a fiber density varying from inside to outside. So as you go to fiber density, so basically the entire culm is formed by the combination of fibers which are distributed at certain space, densely distributed at inside the bamboo structure. So typically we can grade bamboo depending on the type of diameter, type of species, etc. So if you look at the availability of bamboo, why we are talking is because of the huge availability across the globe. 1400 plus species are found worldwide, approximately 13.90 area with 136 species in India itself. So for Indian people, Indian researcher, Indian civil engineer, that's a very big motivation that they can think about bamboo as a sustainable construction material. So grow towering heights up to 30 meter. Certain species of bamboo can even grow up to 90 centimeter in one day. It is possible to actually watch bamboo grow because of the rate of the growth. And India is the second richest country in bamboo genetic resources after China. So this factor definitely contributes or encourages the use of areas in India. So within India, you can see the entire map is divided into 7 different regions, talking about a percentage area and growing stock. So different usage of bamboo apart from the construction are like paper, internal consumption, scaffolding, illegal export, handicrafts, miscellaneous. So yes, there is a lot of scope because the availability is huge. Now, why we are talking bamboo? Because of the certain properties, like it absorbs carbon dioxide, it grows fast, it is a renewable and soil erosion, it is versatile, it has a versatility in growing conditions, and that is why we can definitely use to think about bamboo compared to wood structure and compared to concrete structure. Of course, it has limitations. We will see that also, but these limitations can be overcome with certain technological advancements. So bamboo versatility in building, if you look at this, so ultimate compressive strength, this graph basically compares the conventional concrete versus bamboo reinforced concrete. So if you compare the both materials with respect to 6 different compressive strength, the tensile strength, and the bond strength and the modulus of elasticity. So this is a picture which is very promising in case of bamboo. And if you compare it with respect to steel, so this is how it stands. So it's obviously less than steel in most of the case, but yes, there are certain properties like tensile strength and the modulus of elasticity, which for certain species is very high. This is typical comparison between mild steel and concrete and bamboo, which talks about the mechanical property comparison and thereby help us in understanding the use of bamboo. So normally bamboo used in civil engineering is broadly classified into 4 types: whole come bamboo in process or columns, bamboo fibers which are extracted from the bamboo culms and then used in structural concrete, split bamboo, like we are dividing the bamboo culm into different strips and utilizing it as a reinforcement inside concrete members, and bamboo laminated fibers. So again, the fibers are processed to create plywood-like sheets, which are known as bamboo laminated fibers. So these are the 4 major ways using bamboo inside civil engineering. But of course, these are not limited, but the most common ways are there. So this picture basically talks about the use of bamboo as reinforcement. So here the bamboo strips are being uh, taken out separately. They are treated and they are designed to prepare the bamboo cage, that is the reinforcement cage, which can be used inside the concrete. This picture talks about how the fibers can be extracted. So from the strip to the small piece of the bamboo, then extracting it further like a jute fibers. These fibers are further processed to use inside concrete and at different dosages. So, like I said, this is one more bamboo laminate. So, bamboo right from the root, they are converted into culms. Culms are then further divided into strips, which are also known as bamboo splits. Then splits are shaped to get a certain static shape, and then under certain temperature and pressure, they are converted into a laminated sheets. So, this particular picture talks of the bamboo from its origin to the final application. These are some of the pictures which help us in understanding how bamboo are used for construction of houses or structures like this. So you can see trusses are used to create different structures. Now, having understood the different potential of bamboo, we need to also understand the scientific use of bamboo. For that, we should understand the Indian standards, especially, and some international standards. So here is a which talks about the use of bamboo as a material, then design as a design code, and then preservation, uh, and some international code which talks about structural design, determination of physical and mechanical properties. So there have been historical use of bamboo in construction, especially in traditional practices in Asia and South America, vernacular architecture examples, etc. And we are learning from the past. So history is always teaching us in many other ways. So like in case of bamboo also, proven since last few decades that there is a significant potential, especially in terms of mechanical and physical properties inside the bamboo, which are very promising. Structural applications, like I said, bamboo as reinforcement, bamboo scaffolding, load-bearing elements are also used in case of structural applications. Recent innovations using bamboo: reinforced concrete panels, laminated beams, modular housing systems. These are some latest technological advancements. So I have taken 4 case studies where bamboo is used as a reinforcement in structural concrete. So I during my PhD on the different aspect of using bamboo. So first one was nothing but understanding the bamboo concrete interaction. So that was done using bamboo concrete bond behavior, because that's a very crucial issue which needs to be addressed. And bamboo reinforced concrete beams. So we have developed a bamboo reinforcement of which we have even granted patent. So we have a systematic process of developing a bamboo strip reinforcement which can be further utilized into concrete. So this concrete, this ensures the concrete and bamboo, but also enhances the durability issues. So further, we have explored its effectiveness in case of bamboo reinforced concrete beams. So we have tested the beams also, bamboo reinforced concrete slab panels for a limited use. Then bamboo reinforced concrete wall panels. This is the ongoing research work under my BTech project work. So they are exploring the use of bamboo reinforced concrete wall panels, where a lightweight concrete and a bamboo strips are to manufacture a prefabricated wall panel. So it's an industry-based problem which we are trying to find out the solution. So bamboo in green building codes and standard like IS 9096, IS 8242 are some of the important codes. Environmental benefits of bamboo are very well known: low embodied energy, biodegradability, life cycle assessment. Social and economic aspects also, employment in rural areas, women-led enterprises, cost effectiveness and empowerment. Of course, like I said, every limitations and challenges addressed one at a time by doing a rigorous research and development work. So durability issues are very prominent. Joint detailing is very again crucial. Fire resistance and quality control needs to be explored as per the scientific process. Cost versus benefit perception. So it's like return on investment. So how much amount of money and efforts are being put to get the use of bamboo, that needs to be seen from financial perspective. Limited awareness in tier 2 and 3 cities, especially in rural areas, the this is very less. So awareness in the form of education and knowledge needs to be ensured. Regulatory gaps, especially policy implementation, also plays a crucial role. So in India, there are different boards like Bamboo Society of India and National Bamboo Mission. And few other government organizations are working for this. Basically, they are trying to bridge these regulatory gaps to make the effective use of bamboo into the construction industry. Strategies for wider adoption and treatment, hybrid with concrete and bamboo or steel and bamboo, and conventional materials and bamboo materials. Skill development, of course, it's a skilled labor requirement for bamboo construction is always there. So this can be the wider role. So role of academia and research. So performance evaluation, students' involvement and collaborations with Bamboo Institute can definitely uh, make this sustainable practice more effective and more engaging and more productive. Then after that, it's like bamboo composites are being getting nowadays a lot of popularity, where bamboo fibers are converted into composites by utilizing certain adhesives under heat and pressure treatment. In 3D printing applications, where these bamboo strips and fibers are now utilized for printing 3D concrete structures, using disaster resilient structure, especially in emergency and safety structures. One, since bamboo is very flexible in nature, so these are some of the key highlights. So towards the end, summary and takeaways we talk about, especially from the perspective of bamboo. So bamboo is a sustainable material. We have discussed this. Cross-sectoral integration, civil engineers as change agents, and then civil engineering is at the heart of sustainability. Small shifts in material and methods can have a large impact. This is what ultimately I wanted to highlight in this keynote session, being the theme of uh, sustainable innovations in civil engineering. Finally, if you talk about the acknowledgement collaborators, so it's part of students, labs, and supporting organizations. My work at PCCOE and VNIT Nagpur and fellow colleagues and fellow students. And I always say this final quote for call to action is, let's build not just for today, but for generations to come. So with this, I would like to stop or end my own keynote address. If you have any question and answer, you can always contact me. These are my contact information. Once again, thank you, Dr. Samyak Parekar, sir, for inviting his team, management of GH Raisoni Group, the GS Raisoni University, Saikeda, and students. So hope the upcoming sessions for the researchers, that is their paper presentation and poster presentation, will definitely add more value into their knowledge sharing. Thank you. Thank you so much.
Thank you, sir. So,
Yes.
so now for we extend our heartfelt gratitude for sharing your valuable insights on area, particularly bamboo reinforced concrete during our ICSE 2025 conference. Your expertise and passion for sustainability have inspired us and enriched our understanding. Thank you for your time, knowledge, and contribution to promoting eco-friendly practices in construction. Your presence and presentation have made significant impact. Thank you, sir. Thank you so much for joining with us.
Yes, thank you. Thank you, sir.
afternoon, everyone. Thank you to all the participants for making day one of the conference a success. We are pleased to announce that day two of the conference will be held tomorrow at GH Raisoni University, Sarikheda, starting at 11 a.m. Tomorrow event will include the poster competition, model making competition, the research paper presentation. The day will conclude with validatory program. We look forward to your active participation and continued support. Thank you once again and see you tomorrow.